We now solve this trigonometric equation, that is 5 cosecant of 2 theta minus 3 equals 2, and theta is greater than or equal to 0 and less than 2 pi. So first I'm going to add 3 to both sides. So I get 5 cosecant 2 theta, and this equals 2 plus 3 is 5. Now let me divide both sides by 5. So I get cosecant of 2 theta, and this equals 5 by 5 is 1. Now I'm going to use this reciprocal identity, that is cosecant x. This can be written as 1 over sine x. Therefore, we can write the cosecant of 2 theta as 1 over sine of 2 theta. So on the left side, I write cosecant 2 theta as 1 over sine 2 theta, and this equals 1. Now we cross multiply by 1, or we cross multiply this. So when we do that, we get sine 2 theta times 1 is sine 2 theta, and this equals 1 times 1. We can consider this 1 as 1, and when we do the cross multiply, we get 1 times 1 is 1. So this is the converted trigonometric equation. That is, we have rewritten this given trigonometric equation in cosecant 2 theta as in the form of sine 2 theta. So this is another type of trigonometric equation, and the general solution of this trigonometric equation is 2 theta, and this equals pi by 2 plus 2k pi. That is, when 2 theta equals pi by 2 plus 2k pi, sine of 2 theta will be 1, where k can be an integer. So first, let's solve for theta from this equation. Divide both sides by 2. So we get theta, this equals, we divide this pi by 2 by 2. So therefore, it becomes pi by 4. Plus, we also divide this 2k pi by 2. And when we do that, we get k pi. So this is the solution to the trigonometric equation sine 2 theta equal 1. Since we are told that theta ranges from 0 to less than 2 pi, we will have to find all values of theta. Let's suppose if we plug in k equal to 0, we get the value of theta equals pi by 4 plus this will become 0. So we get one of the value of theta as pi by 4. And let's also plug in k equal to 1. And when we do that, we get pi by 4 plus k is 1. So we get k times pi, which is 1 times pi is pi. Let's simplify this. So this equals pi by 4 plus I multiply and divide this pi by 4. So I get 4 pi by 4 to make it as a common denominator. So we can add these two. Pi plus 4 pi is 5 pi, and this is over 4. And this is clearly less than 2 pi. And so we can consider this another angle. So I put 5 pi by 4 as another angle. And if we plug in k equal to 2, let's see what angle we get. So we are going to get pi by 4 plus, if we plug in k equal to 2 here, we get 2 pi. So this will be pi by 4 plus multiply and divide the second term by 4. So we get 8 pi over 4, which is 9 pi over 4. This is 2 pi and some fraction. So this is clearly greater than 2 pi. So we cannot consider this angle. So we can ignore the value of k here. So only for the values of k equal to 0 and k equal to 1, we get two angles, that is theta equals pi by 4 and 5 pi by 4. We cannot consider the negative values of k, because in that case we may get negative angle, that is we may get sine of a negative angle may be negative 1. So we ignore the negative values of k. So therefore we see that the solution to this given trigonometric equation is theta equals pi by 4 comma 5 pi by 4.